Howdy, AP PreCal. It's Miss Kosh continuing on with more polynomial stuff. So I want to talk polynomial inequalities, but they gave us this lovely little like how-to guide here. But when I saw that it said create a sign chart, and I realized I've been teaching sign diagrams, is what we called them in IB, for many years. So what we did is we put the notes that came straight from my IB class right here. And so I want to work through this first and then go back. Okay, so what happens here with the sign diagram is we want to look and see when are the y values positive, negative, or 0, okay? So, or undefined too. So on this one, I see, that's really hard to tell what I'm looking at, but this is a -3, and there was a 0 at -3, and on this side of it, the values were negative, and then I have an asymptote here at -2. So sometimes we like to draw it where it's like a little dotted line so you can tell it's not equal to that. This is -2. And on, yes, okay, I'm doing things correctly. And then here we have another asymptote at +2. So between -3 and -2 right here, my graph is all positive up here. So we're going to put a positive sign here. Between -2 and +2, all of these values are negative, so we'll put a negative here. And everything bigger than this other asymptote is positive. And that's the sign diagram. That's the whole thing. Okay, so this next one, I have a -3, I have a +1, I have a +5. Notice my graph is going positive, positive, negative, positive. And that's because it bounced here. So it's going to be positive on both sides. Positive, positive, negative, positive, I think is what I just said. Yes, and that makes sense. If they asked you where is it greater than 0, you couldn't tell me it's greater than 0 at -3. It would be, well, I think we'll do an example like that before this video is over. So what features must be considered to draw a sign diagram? Zeros and asymptotes. I'm too lazy to write it out, but I mean asymptotes. Okay, so in IB, this is what I would do next with them. I would give them this equation. And so I would find the zeros, so we could set this equal to 0. Factor out an x, and I know that x is equal to 0 or -4. So then I'd come along here, put -4, put 0, and plug in something. Okay, so since this is quadratic, it's either going to go, well, and we kind of know that it's opening up, so it's going to go positive, negative, positive. But let's check by plugging in a point. So let's plug in, well, 1 is an easy number to plug in. 1 squared is still positive. 4 times 1 is still positive, but positive plus a positive is still positive. Plug in something between here and -1. A -1 squared is positive, +1, and then -4 is going to be negative. And then we can plug something in from over here, say -5. That's 25 minus 20 is positive, and that's what we expected. Okay, on this one we have an asymptote when x is equal to +6. So what I might do with my sign diagram is kind of indicate that it's dotted, it's not equal to 6. There's an asymptote there. So now let's plug in 0 is on this side. I like to plug in 0 when I can. 0, so 1 over -6 is negative. And then plug in 7. 7 minus 6 is 1, that's positive. That all stays positive. And then next one here, okay, so I have a, well, let's see, 3 minus x. This is going to do, I do this on purpose to check, to make sure you're paying attention, because I'm not a nice person. X, right, they made me assign a mug and a t-shirt. X equals 3, and so the other one right here is x equals 4. So I have 3 and I have 4 on my little sign diagram. Let's plug in 0 and see what happens. So 0 gave me a negative, but then I square it, it becomes positive. 0 gives me a positive. This was a positive, and a positive is a positive. That's a positive sign, pretend. Okay, let's look over here. Well, okay, 3.5. So 3.5 gives me a negative, square it, and it becomes positive. 3 minus 3.5 is negative. So this was a positive times a negative is a negative. Plug in something over here, say 5. 5 minus 1 is positive, squared is still positive. 3 minus 5 is negative. A positive times a negative is a negative. And does this make sense? Well, it bounced at 4. So whatever it did on one side of 4, it's going to do the same thing on the other side. Okay, here we go. The next one, we have a 0. When the numerator is equal to 0, so that's when x is equal to 0. And we have an asymptote when x is equal to -3. So I can come along and draw a little dotted line for -3 and a little tick mark for 0. Let's see what happens when I plug in -4. I get a positive over a negative is a negative. Plug in -2, I get a positive over a positive is a positive. Plug in 1, I get a negative over a positive is a negative. Okay, I'm kind of getting tired. Same idea. This just, my 0 here, I have a 0 when x is equal to 2. I have asymptotes. This can factor, or you could solve this. Anyway, it's x is equal to plus or minus 1. Okay, so I've got asymptote at -1. I've got an asymptote at +1. I've got a 0 at 2. Plug in 0, what happens? I get a net positive over a negative, so that's a negative. Plug in, I'm kind of tired of this, sorry. Okay, let's plug in -2, that's a positive, it's bigger when, okay, so that's positive. That was positive, 4 minus 1 is still positive, that's all I care about. Okay, 1.5, so 1.5, that's positive. This would be positive. On, say, 3, negative, and a positive, that's a negative. Okay, now this next one is kind of cool. What happens here is this doesn't factor. It's not easy to complete the square. I can do x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and so I have 25 minus 36 is negative. So this is x is equal to -5 plus or minus the square root of -11 over 2. That's an imaginary number. And so what's happening here is that this graph has non-real zeros. Notice that the leading coefficient is positive. It's going to open up. So like if I were to graph this, it would look something like that. So to do a number line, we're like, all right, I'm done. And that's all we have to do. So that was sign diagrams. And now let's come back to, that was kind of the introduction into what we are now seeing that AP is going to teach us. Okay. This is, anyway, here we go. F of x is the y value. F of x is greater than 0 means it's above the x-axis. If it's less than 0, it means it's below the x-axis. Okay, so consider this. Where does f of x equal 0? At -3. When x is equal to -3, can you see my work? Yes, you can. -1 and +3. Where is it greater than 0? Well, it's greater than 0 from here to here. So from -3 to -1, but it's not, they didn't say equal, so we need soft brackets. And then somewhere else, oh, yes, from 3 to infinity. Where is it less than or equal to 0? So it's less than or equal to 0 from -infinity to -3. At -3 it is equal, so we can use the hard bracket. This is one where I would not give you an option. You'd have to use the correct brackets. Where are we less than 0? From -1 to 3. Oh. Because it can equal, I needed to draw the hard bracket. I was just testing you. You caught me. No, I'm just kidding. I caught my mistake. There we go. And that's that. Okay, so then when they give us an equation, or when they give us something like this, we're going to solve it. We'll make a sign chart, or a sign diagram is what I called it. Test values in the intervals to see if the values in the interval are positive or negative, and then interpret the sign, or interpret the problem. Anyway, it's not so bad. We just have to jump in. Okay. So on this one, solve, it's going to be when x is equal to 3 to -1 and to -4. So I'm going to do my sign diagram. I have -4, -1, and 3, and then I'm going to start plugging stuff in. The easiest thing to start with is 0. Now notice on this one, it's cubic, and it's going to either do something like this, or it's going to do something like that, and so it's going to alternate signs, but we can plug in a bunch just to make sure. Let's plug in 0. This is negative times a positive is a negative. Plug in 4. That's a positive, that's a positive, that's a positive. That'll stay positive. Plug in -2. Negative times a negative times a positive. A negative times a negative was a positive times a positive is a positive. Oh my goodness, are you as dizzy as I am? Okay. -5, that's a negative, that's a negative, that's a negative. 3 negatives makes a negative. Okay, so then I said, where is it greater than 0? So we want to know the positive regions. But it can't be equal, so it's going to be -4 to -1, union 3 to infinity. Cool? Okay, same idea here. We have a -2 and a +5, -2, +5. I see this, so it's going to be the same side. It's going to bounce at -2, so whatever I get for one should be the same for the other, but let's just test to make sure. Plug in 0 because we're lazy, I mean efficient. That's a positive, squared is still positive, minus times a negative is a negative. Plug in, say, 6. Positive, squared is positive. Plug in 6, positive. All that was positive, that's positive. -3. So a negative makes this negative, but then we square it, it becomes positive. A -3 makes this negative. So a positive times a negative is still a negative. And that's what we expected to happen. Okay, so now they're saying solve where it's this equation is less than or equal to 0, so we want all the negatives or 0. So the difference is, the way that they wrote it, we can just say, okay, well, from negative infinity to 5, and at 5 we're equal to 0, and we're good. If they had, I'm going to get a piece of paper, if they had written a slightly different problem, if they had said x plus 2 squared times x minus 5 is less than 0, then you would have to tell me it's negative infinity to negative 2, but it does not include negative 2 because it wasn't equal to 0. Then you pick it up again from negative 2 and you go to 5, and it's a soft bracket there also. Okay. I think that is all the solving inequalities. I'll make another video for determining the degree of a polynomial given a table of values. Come back for more.